In this video, we're going to be simplifying rational expressions. And first off, let's define what we mean by a rational expression. A rational expression is a ratio of two polynomial expressions. And to simplify this, here's our steps. Step number one, we're going to factor everything that can be factored. Step number two, simplify any monomials using our basic exponent rules. And then we're eliminating binomial factors. Now, here's the number one thing that you cannot do. This is a binomial. The bottom is also a binomial. You cannot cancel part of a binomial without canceling the whole binomial. Such as in this problem, we could not mark out just the x's. You can't cancel just part of it unless you're going to cancel the whole entire x plus 3 if it's a binomial. So think of it like this. Anytime you have a binomial, say the plus or minus sign, put those in parentheses. Just to remind yourself, you can't cancel part unless you're going to cancel the whole thing. However, with monomials, notice here with number one, let's go ahead and start working some examples. With monomials, you can cancel pieces. The 20 and the 14 reduce, you can cancel those. The x and the 6 and x squared, you can cancel those because there's no plus or minuses. 20 and 14, let's reduce that. 2 goes into both of those. That leaves you with a 10 and a 7. So you have 10 on top, 7 on bottom. Rules of exponents. If you have 6 x's on top, 2 on bottom, you're going to subtract them. You now have 4 x's. Since there's more on top, you're going to write your answer on top. 10x to the fourth over 7. Number 2, now we are dealing with binomials. You cannot cancel the k's. That is number one rule you cannot do. However, what we're going to do, factor everything that's factorable. 6k minus 36 has a 6 in common. Pull the 6 out of each of those, leaves you with a k and a negative 6. There's the top factored. The bottom is not factorable, but yet again, I'm going to put those in parentheses just to remind myself I can't cancel part without canceling all. K minus 6, the whole thing cancels the whole k minus 6 and leaves you with just a 6 on top. Number 3. Again, we're going to factor except for the top. The top is not factorable. Put it in parentheses to remind ourselves. The bottom, y and y, adds, multiplies will be a positive 8 and a negative 6. You can cancel the whole y plus 8 with y plus 8 and it leaves you with nothing on top. Anytime that you have everything canceled, put a 1 in its place because, again, there's an implied 1 out front. And on bottom, you have a y minus 6. Since nothing else cancels, I really don't need to put the parentheses anymore. Number 4, top, first step, we're going to factor out a 2. So when you factor out a 2, you're left with an r squared minus r minus 20. On bottom, you're going to factor out an 8, and you're left with an r plus 4. Top will factor again. 2 sets of parentheses, r and r. Adds negative 1, multiplies, give you negative 20, is a negative 5 and a positive 4. And again, on bottom, you have an 8 and an r plus 4. The 2 and the 8, look at your monomials. The 2 and the 8 you can cancel. Cancel out with a 2 and the 8, reduce that, you're left with a 1 and a 4. The r plus 4 will cancel with the r plus 4, and on top you're left with a 1 and an r minus 5, which you really don't need to put the 1. And on bottom you are left with a 4. There's your final answer. Number 5. And it says watch out here for a minus b over b minus a. And let's talk about what this is actually equal to. And you've got to be careful with this. I want to go through the steps of why this is true. On bottom, what I'm going to do is factor out a negative 1. And when you factor out a negative 1, the b turns into a negative b, and the negative a turns into a positive a. And you could actually flip-flop those around now. You have an a minus b on top. On bottom, you have a negative, and inside of parentheses, you have a positive a and a negative b. And those would actually cancel then. And you're left with a 1 over negative 1, which is negative 1. So anytime you have like an x minus 3 and a 3 minus x, when you mark those out, they do not mark each other out completely. They always give you negative 1. And here's yet more proof. 3 minus 2 over 2 minus 3. If you were to actually divide that, that's 1 over negative 1, which is, again, negative 1. So let's keep that in mind in this problem. Or again, anytime you need to flip-flop factors, you have b minus a, you need a minus b, then factor out a negative 1. So on top, you have difference of squares. Difference of squares factors into conjugates, plus minus. P times p gives you the p squared. 7 times itself gives you the 49. On bottom, you have a 7 minus p, but you need a p minus 7. So again, what I like to do is factor out a negative 1. And what that's again going to do is going to switch those factors around. P minus 7 cancels with p minus 7, and that leaves you with p plus 7 over negative 1. Now, I don't like to write it like that. I'd rather put that negative on top, and you can do one of two things. You can either write this as a negative p plus 7 with the negative 1 on top, or you can distribute that and put negative p minus 7. Either one of these answers would be fine. Number 6, we're factoring a 3a out of the top. That leaves you with a 4a squared minus 1. You're factoring out a 6, the highest power or lowest power of a is a squared on bottom, and that leaves you with 2a plus 1. Nope, 2a, yes, that's right. This is difference of squares, so it'll factor again, so leave the 3a, and then two sets of parentheses. Difference of squares factors into conjugates. 2a times itself gives you 4a squared. 1 times itself gives you the 1. On bottom, you have a 6a squared and a 2a plus 1. Let's start out with our monomials here, and let's cancel again. Because monomials don't have the plus or minuses, you can cancel out any part. So the 3 and 6 reduces to a 1 and a 2. You have 1a on top, 2a's on bottom. They mark out. Since there's more on bottom, when you subtract 2 minus 1, you're left with 1. Put that answer on bottom. Also, now move on to your binomials. 2a plus 1 cancels with 2a plus 1. So on top of this fraction, you're left with 2a minus 1. On the bottom of your fraction, you're left with just the 2a. Again, how tempting is it to cancel those? But you can't cancel part of the top without canceling the whole thing out. Number 7, the top, we're going to factor out a 2. You're left with 3n squared plus 4n plus 1. On bottom, again, we're going to factor out a 2 as well. You're left with n squared minus 1. On top, we're going to have to use slip and slide method. Let me come over here to the side. You have n squared plus 4n plus move the 2 or move the 3 to the n. Factor like normal. N and n, a positive 3 and a positive 1. The number that you slipped was a 3, so let's divide by it. And you now have n plus 1. And this will not divide or reduce, so move the 3 back up front, and you have 3n plus 1. So now let's rewrite this. You have a 2, an n plus 1, and a 3n plus 1. On bottom, you have a 2, and then this is difference of squares, factors into an n plus 1 and an n minus 1. Look at your monomials first. The 2 completely cancels with 2. The n plus 1 completely cancels with n plus 1, and it leaves you for a final answer of 3n plus 1 over n minus 1. Okay, next problem, number 8. On top, we're going to factor out a 5. And you know what? In order to flip-flop these, I'm actually going to factor out a negative 5. When I factor a negative 5, and because I notice when I factor these bottoms, I'm going to have the w first. I don't like the w being second. So when I factor out a negative 5, I now have a negative 9 and a positive w. And I don't like the order there, so I would flip-flop those around and put the w first and the minus 9 second. So when you factor out a negative, if you ever need to flip-flop these terms, factor a negative out and it will. On bottom, we're going to, you can't pull out a 3, so we're going to have to use slip and slide again. So you have w squared minus 28w plus 27, two sets of parentheses. You have a w and a w, a negative 27 and a negative 1. You slip the 3, so now divide by it, and you're going to be left with, on bottom, a w minus 9 here, and a 3w minus 1 when you slide the 3 back to the front. W minus 9s are gone, and it leaves you with a negative 5 on top and a 3w minus 1 on bottom. Okay, in the next section, we're going to be multiplying these rational expressions. And multiplying, if you can simplify these, multiplication is going to be extremely easy. Here's your steps. If it's a monomial only, multiply them together and then simplify them. However, sometimes I'll go ahead and cross cancel before I do that, especially with the numbers. But you can multiply and then cancel afterwards. If it's a binomial or a trinomial, factor everything that you can first and then simplify. So let's go to number 9. And again, see if there's anything like the 6 and 18 that you can actually simplify before you multiply. Leaves you with a 1 and a 3. The 2 and 10 leaves you with a 1 and a 5. So when you've got these together, you have a 5 left on top and a 3 left on bottom. However, if you would like to go ahead and you can cancel x's, or you can go ahead and multiply x's, either way. I have 2 x's on top, 3 more on top. That's a total of 5 on top. I have 3 y's on top, 4 more. That's a total of 7 y's on top. On bottom, you have only the 2 x's. And you have 2 y's and 2 y's, which gives you 4 y's. Now you can simplify those, or again, like I said, you can simplify them before you multiply either way. 5 on top, 3 on bottom. You have 5 x's on top, 2 on bottom. Subtract them, that leaves you with 3. They're going to be on top. There are 7 y's on top, 4 on bottom. Subtract them, that leaves you with 3 y's on top. So there is your final answer. Number 10. Again, if you'd like to cancel the numbers first, that's a 1 and a 3. To me, it just is easier. That gives you a 1 and a 3. So you can go ahead and multiply numbers if you'd like to. On top, you have a 1. On bottom, you have a 9. The A's, again, if you would like to go ahead and mark 2 out with a 4 or whatever you want to do, or you can go ahead, I like to combine the variables before I cancel. On top, you have 2 A's, 3 A's, that's a total of 5 A's. You have 2 B's and 6 B's, so that would be 8 B's. You have 1 A and 4 A's, that's a total of 5 A's. And on bottom, you have 3 B's and 7 B's, that would be 10 B's. So you now have the 5 A's cancel completely with the 5 A's. 8 B's on top, 10 B's on bottom leaves you with 2 B's on bottom. So you're left with only the 1 on top and a 9B squared on bottom. Number 11. Now you're dealing with polynomial terms instead of monomial. So let's go ahead and factor everything that we can factor. Here, you're going to factor out a 4x. You're left with an x minus 1. Over here, we're going to factor out a 2. You're left with x squared plus 2x minus 3. That'll factor again. Up here, 2 sets of parentheses. An x and an x gives you an x squared. Adds to give you 1, multiplies to give you a negative 6 will be a positive 3 and a negative 2. On bottom, let's factor out a 4x, and you're left with an x plus 2. Now, instead of having to rewrite this whole thing again, let's go ahead and factor this. Adds, multiplies would be a positive 3 and a negative 1. So that'll be x plus 3 and x minus 1. There we go. Now everything's factored, and you do the same thing. You can deal with your monomials first. The 4x here, the 4 and the x both completely cancel each other out. The 2 cancels with nothing. 4 x's are gone. So now let's move on to our binomials. X minus 1's top and bottom cancel. X plus 3's top and bottom cancel. I believe that's everything. So you are left with on top an x minus 2. And on bottom, you are left with a 2 and an x plus 2. And you can leave it like that, or you can distribute it out. X minus 2 over 2x plus 4 would be fine as well. Okay, next up, number 12. Top left, you're going to factor out a 5 and a v. You're left with a 2v, or excuse me, a 2 minus v. And again, I don't like that. I don't like the v being last and the number being first, because everything else that we're going to factor is going to have the variables first. So here's what you do. Instead of factoring out 5b, factor out a negative 5b. That's going to flip-flop these two. And that's going to look like everything else that it's going to cancel with. On bottom, 2 sets of parentheses. V and a v adds, multiplies would be a negative 9, negative 2 times 2 sets of parentheses. V and a v adds, multiplies would be a negative 9 and a positive 1. On bottom, you have a 15v. Let's cancel our monomials first. You have the 5, negative 5, and the 15 leaves you with a negative 1 and a, let's see, divided by 5 leaves you with a 3. The v cancels complete with a v. And again, you can cancel out the pieces of that because it is a monomial. It doesn't have a plus or minus. Now the binomials, v minus 9s are gone, v minus 2s are gone. And all that you're left with is a negative 1 on top and a v plus 1. And on bottom, you are left with a 3. So we can distribute that negative 1 on top if we'd like to. So a couple of different ways you can write your answer. You could do this and move the negative to the bottom. There's one way. Or you could distribute the negative on top, negative e minus 1 over 3. Either one of these answers are fine. Okay, next up we're going to be dividing these. Now if you don't remember how to divide fractions, to divide two fractions you flip and multiply, or you multiply by the reciprocal. So all we have to do, there's one extra step, you have to flip the second one and multiply. So what I'm going to do, you can factor first if you'd like to. Now these don't have to be factored because they're monomials, but you simply do 5pq over 16p to the third times the reciprocal, which would be 8q to the fifth over 35p squared q squared. Flip and multiply, that's it. And then do the exact same thing we just finished up with. Since these are monomial terms, cancel out each piece. 8 and 16 leaves you with a 1 and a 2, so you're left with 1 on top and a 14 on bottom. Let's count our p's and q's. There's only 1 p on top, but there are 6 q's. There are 5 p's on bottom, 5 p's, and there are 2 q's. So now we can cancel across the fraction bar, 1 on top, 14 on bottom. The 1p on top, 5 p's on bottom, when you subtract would leave you with 4 p's on bottom. 6 q's on top, 2 q's on bottom, subtract would leave you with 4 q's on top. So really no need to put the 1 anymore. There's your final answer. Next problem. Again, you can factor. I like to go ahead and factor it where it's at. Like this top here is going to factor into, pull out a 2x, you're left with an x plus 3. The bottom here is going to be 2 sets of parentheses, x and x, adds, multiplies as a positive 3 and a negative 2. This turns into 4 parentheses x minus 2. Now, why did I do that? So that when I rewrite it, I've got it factored when I flip and multiply. So times the reciprocal of the other one will be an x plus 3 and an x minus 2 on top, and a 2x and an x plus 3 on bottom. Flip and multiply. Let's cancel out all of our monomials. The 10 and the 2 leaves you with a 1 and a 5. Let's see, that's about it. The x minus 2's will cancel each other out. The x plus 3's are on top and bottom. So on top, you are left with simply the 5. And on bottom, you're left with a 4 here and an x here. So 4x, 5 over 4x. Number 15. Again, I'm going to factor it where it's at so that when I flip and multiply, I don't have to factor in a different step. So we're going to pull out a 2 and an a squared here. You're going to be left with an a minus 6. You're going to be left, let's see, we'll go ahead and factor the bottom next. Adds, multiplies is going to be a negative 6 and a positive 2. Here we're going to factor out an 8a squared. You're left with a 3 minus a. But again, we don't like that. We want the a first, so let's factor out a negative with it, and that's going to flip-flop our a and our 3. And then on bottom, 2 sets of parentheses, an a and an a, negative 3 and a negative 5. So now I'm going to flip and multiply. That'll be a 2a squared times a minus 6 over a minus 6 times a plus 2 times the reciprocal, which would be a minus 3 times a minus 5 over negative 8a squared times a minus 3. Now let's see if anything's going to cancel. Let's start with our monomials. 2 cancels with negative 8 and leaves you with a negative 4. You can put the 1 on top if you'd like to. A squared and a squared will completely cancel each other out. A minus 6's on top and bottom are gone. A minus 3's on top and bottom are gone. So that only leaves you with an a minus 5 on top and a negative 4. Always put your number first, a negative 4 and an a plus 2 on bottom. So that answer is fine. Or again, you can write this as a minus 5 over negative 4a minus 8 if you'd like to distribute it out. And number 16. This one looks pretty tough. Now you have division and you have multiplication. The rule is in order from left to right. So we're going to divide and then we're going to take our answers and multiply. Or to divide right here, you can just flip and multiply by that. So that's going to be k plus 3 over k times the reciprocal of this term. So that'd be 1 over 4k plus 1. Then to take that answer and then multiply by this, you could just go ahead and write this out here. Top is going to be difference of squares, which will factor into conjugates. So plus and minus, that'd be a 4k times itself gives you 16k squared. 1 times itself gives you the 1. And a k plus 3 on bottom. So now let's do some canceling. K plus 3s are gone. 4k plus 1s are gone. And I believe that's everything. So you're left with a 4k minus 1 on top, and you're left with simply k on bottom.